Okay, let's dive right into this explainer. We're going to explore the invisible, life-saving rulebook that literally prevents absolute chaos in our three-dimensional skies. It's something that affects every single one of us who's ever looked up at a plane or boarded a flight, yet it operates completely out of sight. We're talking about ICAO's Annex 2, more commonly known as the Rules of the Air. So picture this. You're thousands of feet in the air, soaring through the clouds. And suddenly, out of nowhere, another aircraft appears on a collision course, flying directly at you at 8,000 feet. You're both moving at hundreds of miles per hour. You've got literally seconds to react. So what happens next? Who moves? Which way did they go? Well, the answer doesn't rely on guesswork or, a polite wave out the window. It relies on strict statutory rules that we're about to uncover. To see how this all works, we're going to look at aviation's legal architecture in four distinct layers: general rules of the air, visual flight rules, instrument flight rules, and finally, the right-of-way rules. Starting with part 1, general rules of the air, the baseline of the sky. Now, these foundational laws apply to absolutely every flight, no exceptions. And it all begins with the PIC, the pilot in command. The rules clearly state that the PIC has ultimate authority and responsibility for safety. That means they are strictly prohibited from negligent or reckless operation. But here's the fascinating part. The rulebook actually gives the PIC the legal right to break the rules if, and only if, departing from them is absolutely necessary to save the aircraft. I mean, that is a massive amount of responsibility placed squarely on one person's shoulders. Beyond just authority, these general rules set strict physical boundaries, like minimum safe heights. So unless a plane is actively taking off or landing, they can't just buzz right over your house. The statutory rule dictates that aircraft cannot fly lower than 1,000 feet over congested cities, towns, or open-air assemblies of people. And just to be super precise, that 1,000 feet is measured from the highest obstacle within a 600-meter horizontal radius of the plane. Okay, what's really interesting is looking at what pilots are legally allowed to drop out of a flying plane. You'd probably think the answer is absolutely nothing, right? Well, the 1937 aircraft rules actually have some highly specific and honestly slightly humorous legal exemptions. You can drop fine sand or water for ballast. In an emergency, you're allowed to dump liquid fuel or even cargo to avoid a hazard. You can drop message bags or smoke apparatus for navigation. And brilliantly, you can legally drop flower petals. Seriously. But provided you have the written permission of the district magistrate, the aircraft is suitable, and you take strict precautions not to injure anyone down below. Moving on to Section 2, Visual Flight Rules, or VFR, Flying by Sight. As we get into specific operational rules, VFR is exactly what it sounds like. It relies on visual references outside the aircraft. You spot landmarks, you monitor visual signals from the ground, and you maintain strict ceiling limits. It's highly cost-effective, sure, but the very moment visibility drops or cloud cover becomes too dense, VFR operations must legally cease. You absolutely cannot fly VFR into a thick cloud. To put clear weather into a strict legal sense, take a look at the visual meteorological conditions, or VMC, required in uncontrolled Class G airspace above 10,000 feet. You need to have at least 8 kilometers of forward visibility. And you can't just skim the clouds either. You have to maintain a physical buffer of 1,500 meters horizontally and 1,000 feet vertically from any cloud formation. If you can't guarantee those exact distances, well, you cannot fly VFR. Which brings us to Section 3, Instrument Flight Rules, or IFR, the commercial backbone. Obviously, commercial airlines don't just cancel flights every single time it gets cloudy. While VFR relies on outside visual references, IFR relies entirely on certified cockpit instruments. By trusting their altimeters, their artificial horizons, and by continuously reporting their position to air traffic control, trained pilots can fly safely, completely blind to the outside world. Now, naturally, navigating this way is incredibly complex and requires significant additional training, rigorous examinations, and specialized instrument ratings. Because an IFR pilot can't just look out the window to figure out where they're going, the preparation is, well, it's incredibly intense. Just look at this rigorous step-by-step planning process a pilot has to complete before an IFR flight even leaves the tarmac. They have to analyze meteorological conditions. They check NOTAMs, or notices to airmen, for unexpected hazards along the route. They meticulously select specific routing corridors, including standard instrument departures and arrivals. And they calculate exact en route times and fuel endurance for every single leg of the journey, factoring in wind velocity. Honestly, it's a total masterclass in risk management.
All right, on to Section 4, Right-of-Way Rules, the climax of collision avoidance.
So even with all that great planning, aircraft do cross paths, which brings us to the ultimate tiebreakers. In the event of a traffic conflict, there is a strict hierarchy of the sky, and priority actually isn't given to the biggest or the fastest plane. It's based entirely on maneuverability. The least maneuverable aircraft inherently have priority. This means balloons hold the highest priority of all, simply because they just float with the wind. Then come gliders, airships, and aircraft towing objects. At the very bottom of the priority list, meaning they have to yield to literally everyone else, are the highly maneuverable powered aeroplanes and helicopters.
So let's test this out with a real-world scenario. Let's say two powered airplanes are converging. Airplane A is heading due north. Airplane B is heading due east. They're intersecting at the exact same altitude. Neither is a balloon, neither is towing anything. It's a dead tie in the hierarchy. So according to the rules of the air, who has to give way? Well, the statutory rule here is elegant and absolute. The aircraft that has the other on its right shall give way. Think about their positions for a second. Airplane B is coming from the east, which puts it on the right side of Airplane A, which is heading north. Because in the sky, right is right, Airplane A must yield. So Airplane B maintains its speed and heading, while Airplane A alters its course to pass safely behind it. And this brings us right back to our opening question. What happens when two airplanes fly directly at each other? When it's a pure head-on encounter with a danger of collision, the rulebook definitely doesn't leave it to chance or, a terrifying game of chicken. The rule dictates that both aircraft must immediately alter their heading to the right. By both steering right, they safely pass clear of each other, port to port. Now, what if you're flying faster than the plane in front of you and you need to pass? In aviation, you don't pass on the left like you might on a highway in many parts of the world. The aircraft being overtaken always has the right of way. The overtaking aircraft must alter its heading to the right, passing well clear. And importantly, no subsequent change in position absolves the overtaking aircraft from this duty until they are entirely passed and clear of the other plane. Finally, we have to look at landing priority. The rule here is super simple. Aircraft that are in the final stages of an approach to land always win the right of way over aircraft in flight or moving on the ground. If multiple planes are approaching this same runway, the aircraft at the lower altitude has priority. But there is a crucial caveat here. Pilots absolutely cannot abuse this rule by dive bombing to a lower altitude just to cut in front of an aircraft that's already established on its final approach. That is a huge no-no.
And really, this all brings to light the immense split-second responsibility that pilots bear on every single flight. The rulebook is elegantly designed, perfectly balancing right-of-way, weather conditions, and ultimate pilot authority. But applying these invisible rules in a 3D environment while moving at hundreds of miles per hour takes intense focus and training. So knowing what you know now about the highway code of the skies, are you ready to be the traffic cop up there? Thanks so much for joining me in this explainer. Next time you look up, you'll know exactly the laws keeping those planes